So welcome. Good afternoon. My name is Greg Valoria from the Nerd Soccer Media Network. And on behalf of the Cal Poly Graduate Program and Graduate Education Program, we thank you for attending our information seminar on Want to Know More About Print Electronics. So I'll be moderating this session and also the question and answer period. So before we start, I want to do some housekeeping. For those who are on the Hangout Live, we don't have anyone now yet, but if you can mute your microphones, because then we just want the presenters to speak. But if you're lucky to be in the Hangout, you can ask the questions on the live Q&A session. But if you're viewing this on Google Plus Hangouts, which I think I see a couple of people doing that, to ask questions during the session, there's a grid of 9 boxes in your upper right corner, which is next to a question mark on your window. And if you click that, a QA button will appear. And you press that, and your right-hand side of the screen will be an area where you could type in questions, and I'll see the questions on my screen as the moderator, and we'll be able to get to those. So just take some time to do that right now while I'm talking about the agenda. So with this seminar, we hope to give you a glimpse of printed electronics and the Master's of Science program at Cal Poly University San Luis Obispo. And so let's go through the agenda. I'll be introducing today's guests, Professor Malcolm Keif of the Graphics Communications Department at Cal Poly, who will also discuss kind of a brief info into printed electronics and the graduate program. And then Professor Xiaoying Rong of the Graphics Communications Department as well, who will talk about some of the great research topics they're working on at Cal Poly University. And if we're lucky, we have a industry guest, Mr. Raghu, CEO of ID Tech X, a company which researches and does business intelligence on this up-and-coming industry and other emerging technologies. And he'll give you an industry overview. And if he's running into some technical difficulties right now, and if that doesn't happen, we'll just go into a Q&A session, and I'll also discuss with Malcolm and Professor Rong about some of the what they see as some of the emerging things coming on in this industry. So each of them will speak around 10 minutes. They'll have a slide presentation, and they'll talk over that, and then we'll open it up to questions right after that. So anyway, I guess we'll get started here. So let me introduce the next speaker here, Professor Malcolm Keif, and a little bit about Professor Keif. He's been at Cal Poly since 2001, and he's been passionate about print electronics for over 10 years, and over the last few years been developing ways of training people in the upcoming growth area called print electronics and functional imaging. And it's culminated now in starting this year, a certificate program in print electronics at Cal Poly University, and a master's program, partnering with Professor Rong, who will be also talking today. So, Professor Malcolm Keif, take it away, please.
Great. Thanks so much, Greg. Appreciate it. And it's a real pleasure to be with you today. I'd like to call up a little PowerPoint and share my screen if that's all right. So I'm going to do this. Let's see. Oh, I didn't do it right. Sorry about that. One more time. We're going to try this.
No problem. Yeah, this is a pretty exciting area that you're going to be talking about. So
it's not cooperating with me at the moment, but
that's all right. Yeah, that's right. Let me know. I'll let you know when you're online. But yeah, I've been working with Professor Keif for a few months on doing these online information sessions here on Google Plus Hangouts, and it's a new medium for Cal Poly. So we're trying this out and trying to work with people not only locally in Cal Poly but around the globe and connected to Google Plus. So we're kind of excited to kick off this second program in graduate electronics, and I think it's pretty exciting, this new medium that they have, which is Google Plus Hangout, to try to get our message across. So how's it going, Professor Keif? You doing okay?
I'm not going to be able to share my screen, but that doesn't matter. I am going to tell you about print electronics and tell you about our master's degree. So let me just tell you a little bit about print electronics. Print electronics is the additive depositing of conductive, dielectric, reactive style inks. And these inks are basically designed to be able to add function to a flexible substrate. So that's what we're really talking about. We're talking about this printed or printing of electronics on flexible substrates. And it's using fairly common printing equipment, which is part of the key and the novelty of this. So you might wonder, well, okay, so why do I think that we can print electronics? And the answer really lies in the flexibility. We know there's a movement towards wearable, foldable, bendable, rollable kinds of technologies. And in order for these technologies to come about, they have to be on a flexible substrate. So flexibility is really the key. And for the most part, the electronics industry is built around rigid substrates. They're built around silicon fabrication. And so this flexible world is a real new world to us, and it's one that bodes well for those who are interested in the additive manufacturing models of printed electronics. So that's really what we're focused on here at Cal Poly and why we're launching this master's degree program. We have at Cal Poly more than 70 years of history in printing, but again, that's more graphic printing. So we're now moving into this more scientific realm where we're having to be much more precise. We have to have much better registration tolerances. We have to have much better understanding of fluid mechanics and roll tensioning systems. But we've been building towards that, and that's why we think that we can offer that to different folks. So that's really where we're focused. We're focused on this model, this printed electronics model. Some of the things that we know that we can print right now, and I had some samples to show you in this slide presentation, but it doesn't matter because I can tell you about them, is it's really easy right now to do the fabrication part of it, the printing part of, say, batteries, or it's really interesting to do the fabrication part of, say, electroluminescent displays. It's really easy to do the fabrication part of, say, other kinds of static displays, photovoltaics, the fabrication part of it. So there's a lot of work that has to be done in the material side, but it's interesting to be able to see what we can do in the sense of being able to produce these things using fairly conventional printing equipment. So that's why we're really optimistic about this. Now I wanted to talk just a little bit about this Master of Science degree because we at Cal Poly are launching a degree program where we are going to be preparing people for learning about the production, well, actually learning about the design, the electrical performance characteristics, learning about the imaging side of how to produce image the plates. We're preparing students to understand the production capabilities, the quality control side of it, and then what the whole market looks like for this up-and-coming future area that we call printed electronics. So this course of study called this Master of Science degree in printed electronics and functional imaging focuses on 3 areas. It focuses on the actual printing of electronics. It focuses on what we call smart and intelligent packaging, so using active materials for packaging, which could be electronic materials, but it could also be other kinds of materials that, say, are reactive or create certain barriers, or they might be scavengers. These materials that basically add functionality to packaging. And then the third area is the security or the anti-counterfeiting realm, where we can use printing technologies to improve the security of items and to make sure that items have maybe either some optical patterning or some type of technology that would allow us to identify if counterfeiting has taken place. So these are the 3 areas we're really focused on. And the actual Masters of Science degree is structured such that it has 5 online courses. So a student could theoretically start the master's degree without ever arriving at Cal Poly and maybe do those 5 online courses in year 1, for example, and then they can show up on campus for year 2 and basically work within our labs and do the research that Professor Rong is going to share with you a little bit about, which is the research side of it. So we have 5 online classes. That leaves 27 units of on-campus classes, which equates to around 6 or 7 additional classes. It's very team-focused, project-focused, research-focused, and then our students, when they graduate, we presume will go out into this emerging industry and basically fulfill roles that might have an R&D role, it might have sort of a tech development role, it might have a product development role, but we see our students going out into both, Silicon Valley focus, but also consumer products focus. We have a lot of interest from the consumer products world because they want to know how they can implement these things into their packages, into their displays, things of that nature. So that's our master's degree. If someone were interested, they should go, and I know we'll have this up later, but they should go to printelectronics.calpoly.edu. And there's a tab up there called Master of Science degree, and it talks a little bit about the requirements to apply for this. But if you go there, you'll see that you do have to fill out an application, and right now is the time to do that. The applications will continue through April 1st, I believe, is when the application period closes. We'll need 2 letters of recommendation. Because it's a graduate program, a master's program, you will need to take the graduate records exam, the GRE. If you have the GMAT already done, talk with me and we might be able to work with that as well. So that's the key. For international students, we welcome international students as well, but you will have to prove English, a level of English literacy, so you'll take the TOEFL. But we're actively recruiting right now, and we look forward to inviting students here to Cal Poly.
That's great. Okay, well, thank you, Professor Keif. Do you have anything else to add, or you're all set there?
I'll let you pass along to Professor Rong. In the meantime, I'll see if I can figure out how to share my screen, and then
okay, no problem.
Maybe if I left anything out, we'll jump back.
All right, thanks, Professor Keif. So anyway, next up we have Professor Xiaoying Rong of the Graphics Communication Department. So a little bit about her. Professor Rong joined Cal Poly in 2005. She has strong printing background along with experience in materials development. Professor Rong has been involved in print electronics since 2006, and since then she's worked on many projects related to the fundamental studies of printed functional materials and integrating printed electronics with graphics. She's actively worked with different disciplines on campus and other universities, as well as with other companies from Silicon Valley. So anyway, Professor Rong, please take it away.
All right, thank you, Greg, and welcome everybody to our info session. And I would like to share some of the research and my understanding about print electronics and what we can go what we can learn from this program. So I have a few slides to share with you, and hopefully my sharing works well. So I made a couple of slides, and just to show you what are the research opportunities that you can get involved if you're in the Master of Science of Print Electronics and Functional Imaging, we call PEFI. I'll show you a couple of things to my understanding, and I think it's a very interesting, exciting area. It is we're looking for. And so if you coming in for a graduate program, once you get into graduate program, there's a lot of research work, and you can get involved. And the research work has a different types of research, of course, and you can work on, if you're interested, based on your interest and based on your background. And we can see there are people coming into our program maybe have a different background or from different disciplines, and there's a fundamental study if you're interested in get involved. Of course, there is application-based research if you are more towards the application side of this discipline. So if you are interested in fundamental research, and I think the good point is we will learn, because the program is called Print Electronics, so we will learn printing parameters and how that impacted the quality, but this quality is not graphic-wise, of course, it's related to the function. We will, in the fundamental studies, and you probably will want to understand what is the material and how that responded to different types of printing conditions, and because printing has a different forces applied and the different different forms and different controls, and material will respond very differently in the different processes. And besides that, and as one of the interesting area for the industry, especially for the application side, is to understand, is there any way you can optimize your printing parameters for the best output and to get a best functionality for building electronic devices. And so this area is also very interesting to optimize the printing parameters. There's some parameters I'm going to show you you later with some photographs. And developing and modify the materials for best performance on the press. And we've seen a lot of materials developed from different groups, and especially for the groups that learn more about materials rather than printing. And the material they developed, it has a function they look for, but it may not be appropriate for applied by printing process or other coding process, for example. So a lot of time that fundamental research has related to how do you modify the material and make sure they work on the press, because press require, if the printing process, it requires very specific material characteristics, and that has to be studied and understand a little bit more and to the points that we have it now. If you're interested in application-based research, and I think the good point is there's a lot of work that needs to be done, and you have to understand how to build a circuitry that can be printed. And the semiconductor industry building function is very different as what printing can do. So the circuitry has to be modified, and you cannot just borrow the circuitry that is used in the semiconductor industry and bring it over for your printing purposes. This has to be changed. And what the other challenge is, if you have a circuitry, how do you integrate that with existing products in the different formats, and how do you use that, integrate it with your graphics, or if you're not going to integrate into your graphics, and how do you use that circuitry or electronics to be part of your products without interfere with the appearance of your products, for example. There's a lot of application-related things related. How do I interconnect of the electronics if I have different components as a building blocks, and how do I interconnect all these materials and make sure, and the other part is encapsulation, so make sure that the electronics you build by printing methods would not degrade in the ambient environment when they're being used. And testing and marketing, of course, are the application-based research. And if you're interested in marketing, how this would be applied for different applications, that will be a very interesting area as well. So as I see the PEFI, or Print Electronics Program, is a multidisciplinary area and related to functional and application of both sides. So it would fit you if you're interested in either side. Will find a lot of interesting works that needs to be done and study a little bit more. So the printing process we're looking for, and there's a lot of parameters to control, and here I'm showing two devices on Cal Poly campus, and one is a screen printing device and one is the Flexo press. There's controls for sheet production in the sheet form and production in the wet form, and there's many different parameters in printing and to make a very different quality. And of course, other type of parameters we have to control is how do you build a image carrier. The image carrier has to have a specific resolution and the ability of carrying and released ink, not only carried ink but also released really well. And so some of the
Xiaoying, sorry to interrupt you. Can you arrow down to the slide that you're looking at, or we can't see it online right now?
Oh, you can't see it?
No. Yeah, there you go. Perfect. Perfect.
Can you see it now?
Yes, yes, yes.
Okay, so you
Thank you.
can't really see it on the full screen. I guess that's what happens.
Yeah.
Okay, so I'm going to go back to
Sorry.
my screen share. No worries. Okay, so basically we also have to understand the parameters, for example, the carrier, the resolution, the ability of carrying and released ink. And this is the research we've done in the past few years, including the printing functional material on the Flexo device and also the screen printing device. And so in this case you see a screen printing mesh and with a very fine resolution, and also the plate for Flexo printing also carries a very fine details. And there's a lot of research on that. How do you even get the resolution on the plates? Other type of research work is material related, the characterization of the materials. And for example, if the ink has to be printed with the screen printing or flexography printing or inkjet printing, and what is the specific characteristic of those materials that we're looking for, the rheology and the surface chemistry, what is the mechanical or chemical responses of these materials. Those are all the areas that are very interesting and needs a lot to understand more, and there's research going on. In the process and the parameter, and after your ink is applied or functional material is applied, and the next step will be cure and drying and make it a functional. And so there's different ways of curing it. We have listed in here, and you see 3 different photos in here. There's oven, there's photonic curing, there's UV curing. The purpose is even the different curing devices will bring the functionality in the different levels. So there's a lot of understanding that how is the material react with a certain curing condition. And that's the area very fundamental. When the material is applied or printed onto the substrates, and no matter is rigid or it's flexible, and there's a lot of quality assessments you have to work on to understand and what is this quality of a printing related to the functionality. So we're looking at some of the surface area, some of the three-dimensional structure of the printed features, and understand how that associated with the quality is a big area. A lot of people are spend many times on that and efforts on that. And after everything is printed, of course, you're building a device, and you have to sort of understand what's your electronic performance. So in this photograph was a research done a couple years ago, and it was done with the RFID antenna. And so the picture we're showing here is a chamber to test the functionality of the antenna that built with the printing process. A lot of work to do on that as well. And the other part is for if you're interested in the applications, I showed a few projects we've done in the past years. And so you can look at the top left-hand corner, and you will see origami with the LED lights. And this can be translated into different types of products. If you wanted to, work with that consumer products and bring in the very interesting interaction feature in to the products, and that could be one of the things to consider. And on the upper right-hand corner is a project about the electrochromatic display and with the interaction features, interactive features, and on the magazine cover. So you can, direct the reader into a specific features that could, highlight your products and etc. It could be on the packaging, could be on any type of consumer products. On the lower left-hand side is a interesting product that's a demonstrator that we worked on. Is a temperature sensoring coaster, and I think I have probably the typo in here. And it sensors the temperature. The idea is to integrate some of interesting features and interactions for the product, so the consumer will be interested in your products and bring in the interaction to engage this in the consumer in the product. On the right-hand side and the lower right-hand side is a segment-controlled electroluminescent display. This is a kind of popular things if you're looking at a point-of-purchase display, products display in the different event, because it's segment-controlled, and it's very easy to bring the dynamics to the display instead of being completely static. It's a very interesting feature that, but it's also complicated because you have to build the graphics, you have to build the circuits in that same time, and you also have to consider how do you print it and make it work after it's printing. There's some other product development work that we have done in the past, and the upper left-hand corner is a pocket timer. It's printed on paper, so if you fold it in specific and choose a timer, it'll blink, and when it's done, it'll tell you the time is over, and which is you can have all different kind of applications with that. On the upper right-hand corner is a security microprint, and if you're interested in security printing and improve the security feature of the products, and there's some of the applications we've experienced before. The bottom of this slide and shows 4 pictures in a row, and which is the most recent project that Cal Poly and the University of Munich and work together to have a demonstrator. It's called a Flex Time, and that's their brand. They had a hybrid timer with electron chromatic display. So the hybrid means you do have some semiconductor components and the silicon-based chips and some other resistors and controls. But it is most of the part is printed, and it's flexible, and it can be applied in a different area and for different applications. So you can see on the very right-hand side is our students are demonstrating this timer, put it onto a surfboard. And so it's related to the products. How can the products work? And this involves many different things: the printing, the design of circuits, and how do you interconnect the semiconductor components to a printed component, and of course printing to make it work. So to finish up my introduction, and I think print electronics and functional imaging as a Master of Science program, I think it's interesting the combination of understanding materials, understanding electronics performance, understanding printing, and it's the combination of different aspect or different disciplines of the things we're talking about today. And I hope you find something that interests you to join this program, to learn a little more about this exciting area. All right, so Greg, back to you. Thank you.
All right, thanks, Professor Rong. I really appreciate that. A great slide presentation, by the way. So, anyway, next up we have Raghu. You online there?
I am. Can you hear me okay?
Yes, we hear you fine. So sorry, he was running into some technical difficulties earlier, but he's online now, and that's all that counts. So a little bit about Mr. Raghu Das. He's the CEO of ID Tech X. He has a MA in Natural Sciences degree from Cambridge University, where he studied also physics. He's been closely involved with the development of print electronics for over 10 years and carrying out consultancy in Europe and US, Asia, and the Middle East, and he follows the emerging markets very closely. So anyway, take it away, Raghu. Appreciate it.
Thanks very much, Greg. And can I just confirm you can see my screen okay?
Yes.
Great.
Thank you.
So I've been involved in looking at a range of emerging technologies for about 15 years, and I think it's always very important to start off with what is the problem they're addressing. And so I thought I'd just spend a few minutes in my presentation just highlighting why people want printed electronics. Why is it that some of the world's largest chemical equipment, OEM, and display companies are investing huge sums of money? What is the problems they're resolving? And as you can see from this slide, it's very broad and very diverse. Print electronics is looking to tackle what I'd call megatrends, and that is the aging. We're now in a position where 2/3 of the people that have ever reached the age of 65 in the history of humankind are alive today. People are living longer and longer, and so we need better ways to help people stay in their homes for longer, better sensing. There's also huge challenges, of course, with the growing population of issues like energy generation, and just how to make sure that, in very dense areas and with a huge population, we can have the best in things like food, logistics, transportation, and minimize disease. Then there are more emotional aspects, so what consumers are looking for. And I think all of us here and everyone listening, want thinner, lighter weight electronics in our pockets. And it's slightly oxymoronic that we want, in the main, larger displays, but we want to carry these around in smaller packages. And really, I think that can only be satisfied by having rollable displays of some sort in the future. If we go into a retail store, people want to have much more product information about the things they buy. Where did it come from? What exactly is in it? How many calories are there? Is it vegetarian, for example? But all of this is at odds with the nature of marketeers who want to use that space to sell the product to you. So they don't want to put all this tiny text on, and there needs to be a much better way to transfer the information that you want to know, as well as enabling the brands sell the product. If we move to enterprise and business, brands, we find, are in a big issue.
Raghu, sorry to interrupt you. Are you on a different slide right now?
No, I'm on the same slide, just down to business needs.
Sorry, I'm just double checking.
Sure. And here brands are looking to differentiate their products, because as you walk into a retail supermarket, everything is trying to make noise, but few really differentiate. And so many of the world's largest consumer goods companies are looking to print electronics to add that wow factor to packaging. And then there are major technology trends. Perhaps 10, 15 years ago, for people involved in printing, they wouldn't think that they would be involved in the very latest aspects like wearable technology or the Internet of Things, but print electronics is the enabling technology for both of those things, in my opinion. So hopefully you can see the next slide, and really what I wanted to show to you is that print electronics is already here today. In all the things that you can see on this slide, it involves some form of printed or potentially printed electronics.
You'll have to get out of full screen. You have to get out of full screen mode and go to manual mode, just like Xiaoying. Sorry about that. There we go. Thank you. We see it loud and clear.
So here you could see a range of applications where print electronics is being used today to solve some of the issues I mentioned in the previous slide. Some are already fairly high volume. For example, in the very middle we have here glucose test strips, and about 25 billion of these are made each year by printing. Then we have what may seem frivolous, but which can really help sell product, and that's the printed battery tester, which appeared at its peak on more than 2 billion batteries each year. Then we've got the opportunity for companies to do something completely new. We have new form factors, as Malcolm said, and so examples of that is e-ink, who created a completely new product in the form of the Kindle, working with Amazon and others. And this is an example of not replacing anything. This didn't replace people's laptop, but it created a huge new market that wasn't possible before because we didn't have this type of technology. The technology is being used today on bottles in the form of smart packaging. These on the bottom left are sold to nightclubs and bars, so that when you go into a bar, you tend to look at them because they're the only bottle that light up and have a moving image on them. And in the top in the middle is Boeing, and Boeing have already rolled out print electronics in some of their aircraft in the form of a very large area sensor. In that regard, they were looking for something that was lightweight and it could be conformal to the aircraft wing to monitor bird strike detection. So print electronics, has enormous applicability, and I really can't think of many other technologies where you can, in one slide show everything from a battery to a Boeing aircraft. And there's much more to come. One of the things that really excites me about print electronics, having looked at it now for around 10 years and studied it closely, is that we're barely at the tip of the iceberg. There's a huge amount more to explore, which will be enabled by doing completely new things. And here are just a few of the things that I think are very exciting. On the bottom right, we have incredibly flexible and rollable organic PV solar. Top right, we have pressure sensors, which were put onto flexible foil, and so it could be curved, in this case, around a hand. In other cases, it could be curved around, for example, gas pipes to monitor hairline fractures in the pipes and detect them early and fix them before. For designers, I think print electronics is going to be a new paradigm in some extent because it enables completely new form factors. And so we see in the top middle lights which are already available for sale. These are not printed as yet, but companies are working on transitioning these new organic materials to these organic devices which can be printed. And on the left we have flexible displays, and there's a huge amount going on in that sector as well. So not only is it somewhat established, but it's also a very emerging technology. I think that's the great aspect about print electronics. It's not a fad. It's not something that will be big in 3 years and then forgotten about in 10 years. It's really the next evolution of most electronics as we know it. In some cases, it will replace products, and people are trying to do that with things like OLED displays versus LCDs. In others, it offers incremental improvements, but in other things, it will create new markets because new things are possible, such as origami electronics. Professor Keif just asked me to talk a little bit also about the global reach of this. We have tracked now over 3,000 organizations at some point in the value chain, from material supply through to people making devices, and that's growing all the time. It's very much a global industry, and there's different trends and needs across each area. For example, in North America, we find that there's really strong product focus and many startup companies. In Europe, there's a huge amount of European funding because the EU believes that this will be a major future key technology for Europe. And in Asia, there's a lot of investment, particularly around the display and PV side. So many of these end devices have common needs, and those common needs include materials, which can be horizontally used across many of the different components, but I think critically also the manufacturing know-how. So while there's been a lot of investment, I think, over the last 15 years in material development, it's been more recent that companies are seriously looking at the manufacturing process, the printing process, optimizing this, improving yield, and getting it to a point where it can be used to make more and more devices in high volume and reliably. And finally, I just wanted to give you a view as to the market size. If you're thinking about getting into the sector, hopefully some ideas to where we are and where it's going. I'd like to point out critically that printed electronics is not a single product. It's many enabling technologies involved in displays and lighting, system components and power supply, others in electrics and electronics. And even today, these are very different points of maturity, revenue, profitability, and growth. We have already 3 markets worth over $1 billion in the form of OLED displays. These are based on new organic materials. They're not printed yet, but companies are working on moving them to printing, and that's where one day we can envisage wallpaper that is your TV set. We have a market for conductive ink, and in the main that is all printed. That's your car windscreen heater, that's the electrodes on the solar cell panels on your roof, and so on. And then we have sensors in the form of glucose sensors, printed piezo sensors, and much more. But you'll see also that there are many technologies which are still emerging. They're still at the point of development where companies are working out what the best application is, and they're working with many partners in the industry to put together ecosystems and consortiums to build prototypes and concepts and do completely new things. So there's a huge opportunity for exploiting what's already there, but also for the creative designers to develop new products, all based around this enabling toolkit of technologies. And we at IDTechX believe that the market, based on all the parameters we look at, will grow to about $53 billion in 2020. That includes printed, organic, and flexible electronics. Not all of that will be printed, but printing will be a key part of it. And ultimately, some devices may be partly printed, partly non-printed, but therein is also a challenge as to how to integrate these different devices. And thereafter going to $70 billion in 2024. And I think, to put it at a high level for you, the LCD industry today is worth over $100 billion. The lighting industry is worth $75 billion. The PV industry is worth $50 billion. And these are existing industries that printed electronics will have some impact on, not to mention all the other things that it will create that we haven't even thought of today. So that's my piece.
Yeah, appreciate it. Thank you, Raghu, and a great presentation, and appreciate that, and thanks for getting over some of your difficulties on your end, but it came out really nice. I had a question for you, just real quick, is that, when you're looking at these numbers, printed electronics is like, we talked about this a little bit offline, is almost like the equivalent of a transistor to vacuum tube, right? It's a shift in technology, right? So does a lot of these numbers, when you look at them, because printed electronics isn't just it's all these things, are the printed electronics numbers going to be included in those industry numbers in the long term?
Yes, I think so, and already to some extent they are. I mean, already there's quite a lot of print electronics happening that people don't even realize, and it's been happening for a long time, such as the printed defoggers on your car or the
Oh,
printed
right.
heating elements in your car seat. I think in incumbent industries like the LCD industry, we've seen OLED displays go from nothing to about $16 billion this year, widely used in Android phones, for example, and that's happened in a period of 4 or 5 years,
Right.
and that is impacting to some extent the LCD market. In others, I think we'll see completely new markets being created. So there's a variety of impact in existing markets, but I believe that in the main, the biggest potential for print electronics is to create new markets and new products, because fundamentally I think what printing offers us is a magnitude reduction in making electronic devices. And if you can, in terms of cost, and if you can do that, then the volumes of these devices can go up by 2 magnitudes. So this won't happen quickly. This isn't something that will happen in the next few years, but it's a long-term program and vision by many companies. But I can start to see us moving from a world where the highest volume silicon chips today are made in a few billion each year, to a world where the highest volume electronic circuits are printed and they're made in the volumes of hundreds of billions, even more each year.
Wow, that's great. Thank you. I appreciate it. So we're gonna move on to Q&A right now, and if anyone's online and they're on Google Plus Hangouts, you open up your QA screen. You could ask us questions. I'll wait for a little bit, but we'll see what we get. There may not be many questions online here, but we'll wait a little bit. But maybe I'll ask a question of Professor Keif. So you said the period for the master's program applications is open right now, right?
That's correct. It's open right now, and it will remain open until April 1st. We're part of the California State University system, so you actually apply through CSU Mentor, which the links are directly off of our printelectronics.calpoly.edu website. But you apply through that CSU application process, and that will remain open until April 1st. This is a new program, so we've actually done the online courses here now. We started those this last year, so we've been working with those, but this is the first time that we'll be having on-campus courses in this space. And so we're looking forward to getting a nice cohort of students in here so we can really get this thing launched well, which is part of why we're involved in this webinar or this hangout.
Yeah, yeah. Yeah, and maybe I have a question for Professor Rong there. Malcolm, but Raghu brought up a very interesting point, is in actually the manufacturability and lowering the cost of that. And it seems like a lot of your research, even though it goes into the fundamentals of printed electronics, but it really moves its way down there if you get that background in the master's program, right?
Yeah, you're right. I think the of understanding printing process is very helpful to mass production, and because printing has its fundamental has not been changed, it could be changed in the future. The material put it onto the printing press has to work with the characteristic of a printing press, existing printing press. So there's a lot of modification, not only on the printing side and how you modify your press and how do you change the imaging technology to change how do you make your plates. There's also the requirement on the side of the material development and how do you develop the material which fit into the printing processes. And so when we put all these pieces together, and then you can see that mass production will become possible to achieve the reasonable and reliable quality and eventually for the volumes.
All right. All right. No, thank you, Professor Rong. That was great. I appreciate that. I guess we'll close off the session. I don't have any questions on my Q&A sheet here on my side. So, but anyway, Raghu, we'll go through all the presenters. But Raghu, you can start. How can they reach you and get a hold of you at ID TechX?
Thank you. You can find us on our website, www.idtechx.com, which is IDTECHEX, or you can email me. It's r.das@idtechx.com. And if I may, I'd just like to also make a closing point that I think what Cal Poly is doing is really important because for the first time we're seeing quite a few very different industries come together. So the printing industry, electronics, and materials, and these industries have never really had to collaborate before in the way that print electronics needs them to collaborate. So I know, speaking to many companies, that there is a demand for people who have this sort of cross expertise and a range of different skills related to print electronics, and therefore I'd like to say we fully support what Cal Poly are doing with this master's course.
Yeah, thank you again. I appreciate that. So Malcolm, how can they get a hold of you and get to the website there? Thank you.
Took me a while, but for some reason the screen sharing decided to cooperate. So anyway, we have these two programs that we talked about, the online courses. And by the way, if anybody's interested in the certificate portion, just the online and not necessarily the master's, we are starting our 501 this January. We're starting another course, so it's time to jump in on that as well. It's a little bit different process for getting in, but again, if you go to our website, printelectronics.calpoly.edu, there's a tab there for the certificate program, and there's a tab for the Master's of Science degree, and we'd love to have you involved.
Great, thank you. And how do they get a hold of you? By email?
Yeah, if you go to the Print Electronics website and you just click on the communication page, that communication does go directly to me, or certainly can email me at mkeif, K-E-I-F, at calpoly.edu.
Thank you so much. And then Professor Rong, how do they get a hold of you?
Yeah, emails is a good way, and my email is xrong@calpoly.edu. And of course, if you are interested in getting to Cal Poly, grc.calpoly.edu is our department website, and you can see our faculty in there, and of course, and websites, and you can
there's great videos there as well. So anyway, I want to thank all of you who not only presented today, Professor Keif, Professor Rong, and Mr. Raghu Das, as well as the people who joined us online. So appreciate you joining us for this information session. And again, we'll be posting this video online at youtube.com under the Cal Poly Grad Education channel. So you'll be able to see that live. And anyway, we appreciate your time and getting us through some of these difficulties we had today. I really appreciate it. So this is Greg Gloria, aka Social Greg on Twitter for the Nerd Stalker Media Network. So on behalf of the Cal Poly Graduation Education Program and the Print Electronics and Functional Imaging Program, we thank you. Thank you again. Thanks, everyone.
Bye-bye. Thank you.